Hello, welcome to this evening's TI Technology webinar hosted by Texas Instruments. You will strengthen students' understanding of fractions with TI-Nspire technology. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough to teach, tough to learn concepts accessible to all students. I'm very happy to introduce our two panelists tonight, Gail Burrell and Tom Dick. Gail Burrell was a secondary teacher and department chair in suburban Milwaukee, Wisconsin for over 28 years. She is currently a mathematics specialist in the program for mathematics education at Michigan State University. She served as president of the National Council of Teachers of Mathematics and as director of the Mathematical Sciences Education Board. Gail received a Presidential Award for Excellence in Teaching Mathematics and the NCTM Lifetime Achievement Award, and is Fellow of the American Statistics Association. Gail is chair of the Commission on the Framework for Advanced Placement Calculus and serves on the College Board Academic Advisory Committee and Advanced Placement Calculus Development Committee. Gail is currently a Senior Mathematics Advisor for Texas Instruments Education Technology and is a TQ National Instructor. Her research interests are statistics education and the use of technology in teaching secondary mathematics and the issues related to what it means to teach mathematics. Thanks for being with us, Gail.
I'm happy to be here, Mike. Thanks.
Tom Dick is a Senior Mathematics Advisor for Texas Instruments and is also Professor and current Chair of the Mathematics Department of Oregon State University. He has served on the educational panels for the Journal of Research in Mathematics Education and the Mathematics Teacher Educator. He remains active in the College Board's Advanced Placement Calculus program and has previously served as chair of the AP Calculus Test Development Committee. He has been recognized by the Mathematical Association of America with its Distinguished University Mathematics Teaching Award for the Pacific Northwest, and in 2008, he was inducted by the Oregon Council of Teachers of Mathematics into the Oregon Mathematics Education Hall of Fame. Thanks for joining us, Tom.
I'm happy to be here. Thanks, Mike.
We are expecting a large crowd, so your audio is muted. Feel free to send questions to all panelists using the Q&A window on the right side of your screen. We'll also be sending messages using the chat window. Once we move to the teacher software, the right section of your screen will be replaced with a floating toolbar. You can access the Q&A window by clicking the question icon. This session is being recorded, and as a reminder, we'll provide a link to the event certificate of attendance at the conclusion of the webinar. And once that recording is available, if you'd like to follow along with your handheld or software, and we really do hope you will, we recommend doing that with recording. That way you can pause the recording, stop, rewind as necessary. We don't expect to have any audio issues tonight, but in the unlikely event that you do, try selecting Communicate in the WebEx menu, choose Audio Broadcast, and click Join. At this point, Gail is going to discuss our agenda.
So tonight we're just really happy to talk with you guys on fractions and the Common Core state standards in mathematics. We're going to look a little bit at the background of what used to be and what is, and then what the vision of the Common Core has set for us. And we're going to explore some examples using some interactive dynamic TNS files, and talk a little bit about the whole suite of materials called Building Concepts Fractions.
Thanks, Gail. And Tom is going to discuss our expected outcomes.
Okay, so what we're hoping participants in the webinar will come away with from this session is actually really finding out a little bit more about what's different about the Common Core's approach to fractions to what they may have thought about traditional teaching of fractions. A lot of our time is going to be spent really exploring this set of dynamic interactive TI-Nspire files that have been designed explicitly to support this Common Core vision. And we're hoping that what you'll see in these files are some opportunities to use technology to help students get a much deeper understanding of the key concepts related to fractions, such as equivalence, ordering, and operations. Finally, this webinar, we see it as it's a way of kicking off a community of folks that can stay in touch with social media. And Michael also alert you to some upcoming events that TI will be having.
Thanks, Tom.
Okay. We're going to talk about fractions a little bit, and I just noticed that Mark von Rosenberg has said fractions are our friends. I only wish students felt that way about them. So I want to just start off by asking, what do you think that students find difficult when learning fractions? What kind of challenges do your kids have when they're learning fractions? So give us a response. What do kids find hard?
I see a lot of people are using that chat window, which is great. That's what we were looking for. Just double check that whenever you're sending us your comments, and they are coming in pretty quickly, that you're sending to all participants and not all attendees. Thanks so much.
So we've got some great responses. Finding common denominators, operations. I love a couple of you have identified that they don't really know what fractions are. They don't understand how to perform operations with fractions. They really don't understand benchmarks. So you guys have picked out a lot of things I can tell that you're teachers because we kind of like know that's what they don't get. And then the next step, once they think about fractions, how do I turn them into decimals and how do I think about fractions in terms of the rational numbers is another huge difficulty thing here. Okay. So thanks for all of those great responses. And you wouldn't be surprised by these results from both the National Assessment of Educational Progress. This happened in both 2003 with 4th and 8th graders. They really couldn't even find where 3/4 was on a number line. And then in 2013, only a third of the kids in grade 4 could figure out the answer to this pizza problem about how they should divide things in thinking about some of the fractions that they have. Again, another fraction problem, this time from Tim's. Kids can't figure out the procedure for finding the difference between those two fractions. And the kind of interesting thing here is that even one of our best states, Massachusetts, only half of the kids in grade 8 could do this, whereas in Korea, 86% of the kids could do this. So there seems to be something out there that some students understand, not clear that we've actually figured it out in the United States.
So what we're going to do here in the beginning of the webinar, before we get into the examples, is talk a little bit about the research background on fractions that underlies much of the traditional approach that we've seen over the last several years, and then take a fresh look at the Common Core state standards and how their approach is shifting some emphasis. And of course, in this webinar, what we're most interested in is taking a look at how interactive dynamic technology like the TI-Nspire platform might be used to create some interactive files that really could support that vision of the Common Core. So this is kind of a complicated diagram, but what we wanted to do is show you a little bit about the research theory that underlies a lot of our curriculum development over the years with fraction constructs. Kind of a central theme is what the idea of fraction is tended to center on is this kind of part-whole relationship and partitioning. And then from that has flowed the related concepts of thinking of fraction as a ratio, thinking of fraction as an operator. And when I say operator, what I mean is when you say fraction of, you're thinking of fraction as multiplication. Fraction also can represent a quotient or division, and then fraction could represent a measurement of a quantity. And then from these, in turn, flow notions of equivalence, and as I said, operator, notion of fraction leads to multiplication, the measurement idea leads to addition, and all of these things come to kind of a boil, if you will, and students have to sort them out when they're trying to apply fractions to problem solving. So how's the Common Core rethought this? It's not going to be, what you're going to see tonight, it's not going to be totally foreign to you, but it is going to represent a very significant shift in emphasis. And the hope has been, with the Common Core's approach, is to try to develop a story around fractions that's consistent and coherent, and so that it's not fractured and splintered in some incoherent ways. A lot of the Common Core approach has been heavily influenced by the work of Professor Wu in the Department of Mathematics at the University of California, Berkeley. He's really, he's a research mathematician, but has been for many years very interested in especially the mathematics content of K-12 mathematics. And he's written extensively about fractions, and his approach to fractions has very heavily influenced the Common Core vision. So what is Common Core trying to do? Well, one thing that it's done besides just list content standards is it's tried to tell a story that's developmental. In grades 1 and 2, students actually start to use kind of informal language. They have a notion of half. The vocabulary of fractions is developed. And then in grade 3, the Common Core starts to lay out some mathematical foundations. And so just as with the traditional approach, certainly partitioning plays a big role here. So shapes are partitioned into parts with equal area. One difference, though, you'll find with Common Core is that kind of ubiquitous model we see of the pizza pie being sliced into pieces. That's something that's actually avoided in large part in favor of models like triangles, rectangles, squares that more easily lend themselves to an analysis of an area interpretation of fraction. There's some problems that come up with that circle model. So a key thing we're going to see is really the central theme is going to shift from the partitioning to the notion of fraction as a number on the number line. So the fractions are built up from unit fractions, and when I say unit fractions, I'm referring to a fraction that has 1 in the numerator. So we think of a single unit whole being divided into equal parts, and then a single one of those then becomes the building block for all fractions. So the unit fractions really play a key role, and that's really developed heavily in grade 4. What that does is actually leverage off students' understanding of the number line in dealing with operations with whole numbers. Okay. So using equivalent fractions to develop the operations of addition and subtraction becomes key. One thing we found in looking at Wu's approach is there's less emphasis on the least common denominator and much more emphasis on just getting a common denominator in order to add and subtract fractions. And for that part, even to do the operations of multiplication and division. Again, what you'll see with the Common Core is they really try to leverage off students' previous understandings. And so their understanding of multiplication and division of whole numbers is played off of to develop multiplication, division, fractions. And then this extends understanding of fraction equivalence and ordering. And then finally, in grade 6, the extension of the understandings of multiplication, divisions, kind of culminates in being able to divide any fraction by any other fraction.
So, as Tom mentioned, the really big key constructs in the Common Core state standards are fraction as a number. And the research literature supports that the fact that this kind of part-whole concept actually had some deficits, that it wasn't complete enough to help kids really develop a good understanding of fraction. And the other big important thing is unit fraction, which again Tom talked about, but using the unit fraction as a building block to develop all of the other kinds of fraction ideas is really key. And then the relationship of fraction being represented on a number line, making the connections between fractions and whole numbers and decimals is something else that's very kind of different from what most elementary approaches to thinking about fractions do. One of the questions that someone actually said something about was common denominators and how confusing that is for kids. And you're going to see that the emphasis here is that the least common denominator is not anywhere nearly as important as the idea of having a common denominator that really sticks out. The way we've been thinking about the fractions has been very clearly tied to the progressions documents. Each of the content areas in the Common Core State Standards has a set of progressions documents that talk about what the fractions or what the content should look like across a grade, from one grade to another, and then within that grade, what these concepts should look like. And so we've stuck very clearly, closely to this documents and the things that it says about fractions. And so you will see that we've taken things and made them kind of like this little picture here. We've made it an interactive dynamic file to help kids understand the way that the Common Core is thinking about fractions. And this is the definition, really, that a fraction, A over B, is really A parts of unit fractions 1 over B, which is the core way of thinking about fractions, and it stays that way throughout all of the fraction work. The other thing that we've tried to do, again, in line with the progressions, is make sure that we've taken these documents, these pictures and these ideas in the progressions and actually made them interactive, so you can see the kind of files that we've developed that support some of the thinking that went underneath the progressions documents.
Okay. So one thing that we're going to be looking at now is how the technology can be used to support this vision of the Common Core. We also want to point out that the Common Core State Standards is more than just about content. It's also about the math practices. And the math practice, there are 8 math practices. The one I think that people think of most closely associated with technology is that of using appropriate tools strategically. On this slide you see here, we've highlighted a few things under the articulation of that particular practice that have really played into our thinking about using technology. For example, we're really looking at using Nspire to help students visualize the results of trying varying assumptions, exploring what the consequences of varying those assumptions are, and then comparing their predictions with data. And ultimately, we're really looking for these tools to explore and deepen understanding of concepts. I do want to stress that I'm not sure how original I would view our work, and we want to give a shout out to a couple of people. Wade Ellis has worked closely with Gail and myself, and we really have, as Gail mentioned, we've taken the progressions and really kind of used those as a blueprint. We've looked at various diagrams within the progressions document and asked ourselves, how could we make that into a dynamic TI-Nspire file? And then what we've done is try to spec out what that would look like. And then we've had the pleasure of working with Becky Beyer, who's a mathematics teacher in Wyoming, who also happens to be a very talented programmer, and when we've discussed what we would like the file to do, she's been able to take that and really create something, and that's what we're going to turn to now and show off a few of the examples. So this very first one that you're taking a look at, I hope that you can see, is a file that we just call What is a Fraction? So this is trying to get across the very basic idea that's laid out in the Common Core Standards of a fraction being made up of copies of a unit fraction. Okay.
Hey, Tom?
Yes.
Sorry to interrupt. Can you do me a favor? I think you might need to share your desktop.
That would be good. Where do I find that?
So at the very top, there's that share menu.
Thank you.
You're welcome.
Good thing you're here, Mike. Okay.
Looks good.
People like that better? Okay.
All right. So this file is called What is a Fraction? And it has a couple of very simple mechanisms that students can manipulate. They can set the partition of the unit into how many different equal-sized parts they would like. That's what the D clicker is up at the upper left. So I can partition it to 9, 8, 7, 6, 5. And then by dragging the point along the number line, I can locate fractions. Now notice that when it does land on a specific number, on the number line, a fraction, it's called out in the symbolic form, but it's also spelling out the vocabulary and how we would say that word, so the 4/3. And you'll notice that there's, if your screen has color, it's making use of color to make that association.
So I want to ask, what questions would you all think about that you might want students who are just thinking about fractions, what would you want them to ask? What would you want to ask them so that they would respond to deepen their kind of beginning just to think about what a fraction is? I don't know how to get to where they can see it. So I'm looking here in the chat. So does anyone have a question that they would want to pose? Okay, so the question is, what would you ask students to think about when they were engaging with this file? What would you want students to be thinking about? Are there any particular misconceptions that they might be thinking about? So we have one response is, I would just want them to play for a while and asks what happens. That's a great question. Someone else says, what is the role of the numerator and denominator? Those are great questions for kids to think about. How do the pieces respond to the denominator? And here's one that I sometimes think about as pretty important. Kids have this huge misconception. Yes, somebody just said that. When the denominator increases, what happens to the size of the fraction? And they have this big misconception that the larger the denominator, the larger the fraction. And playing with the file can probably help them straighten out some of those misconceptions. So you guys are thinking of some really awesome, good questions here. So let's turn to a second file here. And by the way, as I'm doing this, there are other, there's some resources that go along, some questions that are posed for people to think about and to use with students. So let me move this chat thing right here. And here's one that's called equivalent fractions. So that very first file was just to help students get an understanding of what a fraction, the Common Core way of thinking about a fraction is. And by the way, we didn't mention that. Notice here, when I'm thinking about a fraction, we maybe alluded to it, but if I think about this, so one of the questions that we might look at is thinking about the Common Core definition. Are whole numbers fractions? And that can actually pose a really interesting question for kids. But if we use our definition here, that it's 7 copies of the unit fraction 1 over 6, then yes, 6 copies of the unit fraction 1 over 6 should also be a fraction. So whole numbers, according to the way the Common Core thinks about this, are fractions. And you can have them bigger than 1. And those are important things to think about. So as I play with this file, I can change both the numerator and the denominator, and I could think about, okay, are there places that if I look here, I can see 13/6. What if I made this one down to thirds or to halves? Can I compare these things? How can I look at the difference between these kinds of fractions? Again, what kind of questions might you guys want to ask students to think about here? What kind of questions would you think about? What would you want students to consider when they're working on these? One of our really big things is that technology does only what teachers help it do. So if we can't think of really good questions, then we're not really going to, the technology isn't going to really do the job. Someone wants to know, why does it make sense to say 13/6 is greater than 3/2? And the Common Core answer would be that greater than is defined just the same way in fraction language as it is in the world of whole numbers, and the bigger the fraction is, the bigger the number, the farther to the right that it is. So that's an important way to think about that. Other kinds of questions or thoughts or things that people might think about here in terms of how you would use this with students. How to make a whole number a fraction. One of the things that we might point out here is that if I change this, notice that the color coding has actually said that 9/6 matches to that point up there. And so I can actually change these, and there's like clues about what's going on with the fractions. And one question came in, is 0 considered the first fraction? And if I go down here, again, thinking about the definition of the Common Core, we probably would have to think of 0 as actually being the first fraction, or at least, I don't know, it depends on where you call the first. So how do I make, when are two fractions going to be equivalent? What would be equivalent to this? So if I go back down to a third, I can see that 2/3 is equivalent to 4/6. So I can play with the different arrangements, different denominators, change the numerators, and come up with what would look like and turn out to be equivalent fractions. Any other questions or thoughts that you guys have that you want to think about? Let them discover that 2/3 is not equivalent to 3/5. That's great. So I could make this one up here, make it this, and look for 3/5. And I can see that 2/3 and 3/5 are pretty close together, but they're not equivalent because they don't land at the same point on the number line. The definition of equivalent is when two fractions land at exactly the same point on the number line. So I'm going to move now, let Tom talk to you about another example, which looks not just at the number line, but which looks at the area model for fraction. So that would be this one.
I think, go back here. Okay, so the number line is really permeates all of the Common Core's approach, but there are times when the unit, if you think of the number line as representing some kind of units of measure, that unit could be area. And so this file starts out with a page that explores thinking about the unit really being a unit square. So I've got, as I had before, a number line which lets me set the denominator and represent see what particular points on the number line look like as a point on the number line, but it also allows me to start thinking about that in terms of an area model of squares. So this is still the number 4/3, the fraction 4/3, but now represented in terms of partitioning of unit squares as opposed to partitioning of segments along the number line. And then I can see this very clear connection between that area unit and still associated with a point on the number line. So that association will become very useful, especially later on when one's developing or using an area model for something like multiplication of fractions. Gail, did you want to say anything more about this?
Good.
Okay. Here's another page to this file, which starts to let us take a look at the unit square and think about partitioning it into different equal parts in different ways. So in this particular file, I can drag a point and find ways to partition it into different parts. These parts are all kind of congruent rectangles, therefore having all equal areas. And so here, for example, I've got something that is representing 1 of 12 equal parts. So that's 1/12. Once I've set a partition, now what I can do is use that to represent fractions by picking several copies of that unit. And notice that I can, this opens up having fractions represented by a variety of different shapes. Okay, this is quite an interesting file in that it really has quite a bit of flexibility in terms of how things are partitioned up. One could partition the square up into vertical strips like so. The shading doesn't have to be contiguous, so I could shade 2/4 of the square in this way. And so what that opens up is a variety of representations of fractions. Notice that the one thing I really want to emphasize, and it's not that you would never ever use a circle model to discuss fractions, but if you're really going to use the area idea, squares, rectangles, and even triangles are going to lend themselves much better to making that connection to area than the circle model. Okay. Anything else, Gail, that you'd like to add on this particular file? Or?
No, I did see someone asked a question about what application do these play on, and they work on the handheld, they work on the Nspire app, and they also work on the software, obviously. And you can use the player if you don't have a Mac. You can use the player. Hopefully, the Mac version of the player will work, but you can also download the player. You can use them to have kids have hands-on experience, but you could also use them for classroom demonstrations or have kids use some of the whiteboards and be working with the whiteboards and sharing with the class as a whole, using it with the teachers demonstrating some of the software.
It's particularly interesting, I think, to see how these things work on, for example, the iPad as a platform, because there you wouldn't have this this cursor here. You're actually touching the screen directly, and it's really quite interesting. And we've seen the files really work quite well in that setting. Is there another page I should? Okay. Okay. Here's just an example where some triangles are used as a different way of partitioning up areas. Again, I actually have a way to look at lots of different kinds of partitions. So here's one with, well, I'd have to do a quick count here. I think this is actually demonstrating that 24th. And then I could shade the tiles of that unit square in many different ways. So this opens up, if you're having students working on this, having a chance to compare ways of representing the same fraction with different parts of the unit square.
So we're going to look at an adding one and think a little bit about how some of the operations can work. If I can find my cursor. Where does it go? All right.
Okay. This one for me. Okay. So this is a file now where we're getting into looking at the operation of addition and subtraction. And this is where the number line emphasis really becomes quite nice. Okay. So on this file, we can manipulate two segments, links, that represent fractions, and see a comparison to a number line, a point on the number line below. Kind of an interesting question here. Now notice that this particular file is all about adding fractions that have the same denominator. Okay, I can change that denominator. And notice that when I changed this, it really changed it from 4/3 plus 3/3 to 4/2 to 3/2. And so it's some nice connections with thinking about the similarity of those two problems. So what this is playing off of now is addition is now being thought of very simply as taking the links that correspond for measuring, for example, from 0 to the point on the number line, and then concatenating those to think about addition. However, there's another way you might look at this file and see that it could be thought of as possibly representing a subtraction.
So for some of those of you that know a lot about thinking about how elementary kids develop their sense of when they learn their number sentences, their number facts, they write 3 different number sentences. So this would be kind of an example of the different number sentences you could write, where like A plus B equals C, so you can have A equals C minus B, and you can change those number sentences around. And so that's one of the questions you could actually ask here, is what kinds of number sentences could you use to describe the scenario that Tom just has set up for you guys.
Okay. So here is a page on the same file that could be used to think about subtraction. And this file, I would suggest, actually supports 2 ways of thinking about subtraction. If you view this top fraction representation of 5/3, and then view the 3/3 here as being taken away from 5/3, you can see that it's leaving us at the point corresponding to 2/3. But another way to think about subtraction is as a missing addend. So, for example, I could take 5/3, say, well, 5/3 take away 3/3, or 5/3 minus 3/3. What would I add to 3/3 in order to get 5/3? So that's the idea of the missing addend approach.
So questions that you guys I think Tom mentioned that at the very beginning. So they're perfectly happy and don't make it. Did we get kicked off?
Can you all still hear us?
No.
Yeah, I'm not sure how, but I think you became muted for a minute, so I think we're back.
Oh, we're back?
Okay, great.
Whew, I thought maybe we're in a hotel room, so I'm thinking, all right, they kicked us off, so we were on the phone too long or something like that. Sorry about that. So at any rate, I was saying that improper fractions are casually treated. I think the difference between proper and improper fractions is mentioned once in the Common Core. They can even hear the whispers. Usually when panelists do this, they're not in the same room, but we actually are here. Okay, and so while we're thinking about this, I mentioned that there are some materials that go along with it. So there's some teacher materials that support the development of these ideas. And those teacher materials contain some suggested questions that you might want to use. They contain a description of how to use the files, a description of some mathematics, and the mathematical objectives that you might have. And one of the questions that just came said, can we do fractions without common denominators on this file? And the answer to that question is no, you can't. You need another file, which we didn't actually pull up to show you tonight. But that other file, the basic premise is the really big important thing is equivalent fractions. So you have a couple of files that teach kids to think about equivalent fractions when they get to uncommon denominators. The idea is that you have to go back to the common denominator because you're saying A copies of 1 over B plus C copies of 1 over D, and you can't concatenate them on the number line unless they were the common denominator. So the whole idea is to get some kind of an equivalent to same denominator and use the process for getting equivalent fractions to do that. Here's another example of kind of the area thing and tiling that we can actually do the same thing. So I can do something like tile this in a certain way. I can define a certain region of that. So I might define 6 of these, and then I can shade something like this. And then you can ask all sorts of different kinds of questions because I can repeat the same kind of a process over here. And I might ask the students to actually make an equivalent, a representation of an equivalent fraction in this region here. So I could partition it in a slightly different way. I could say, okay, if I define this and this and this, and I shade one of these, are they equivalent? And the kids would have to reason and justify whether they are equivalent or not equivalent. So there's another way to think about whether the size of the unit fraction makes a difference. So I might actually, let's see, what have I got here? I might actually think about something like this, really little and tiny, and now I might do exactly the same thing where I've tiled 4, 5, 6, and now I shade 2, and I can say, are those equivalent, why or why not? So that kids can have this discussion about the role and importance of the unit. And this fraction can come anywhere in this the whole story that we actually want it to. So any other questions or comments or thoughts that you guys have here about things that you'd like us to think about, or things that, questions that you might have about how it works? So while we're doing that, maybe we'll quickly share with you a way to think about multiplication. And I'll go and pull up this file on multiplication. So there are 15 of these files. And this is the one on multiplication. And Tom, do you want to talk about the multiplication one?
Sure. So the multiplication file really works off the area model. And what one does is, with this particular file, you're thinking of the 2 factors as representing linear dimensions along the sides of a unit square. So for example, I was going to model 2/3 times 1/4 I'm thinking of marking off 2/3 along one dimension of the square, so I would break it into 3 equal parts and look at a length of 2 of those equal parts times 1 out of 4 equal parts along the other dimension, and then look at a rectangle that measures that. Now, scoring the rectangle in that, the square in that way, we can see that scoring into thirds along one dimension and fourths along the other dimension breaks the square into 12 equal parts, and the rectangle represented by something that measures 2/3 by 1/4 is exactly 2 of those parts. So 2/3 times 1/4 is 2/12.
And I want to point out that this builds on the notion that how do I find the area of a rectangle? I multiply the length of the base times the height. And so, again, this consistent story about what do I build from? I build from kids' knowledge of finding area, where you multiply the height and the base to find the area. So 2/3 times 1/4 has to be what proportion of the entire, or what part of the entire square has been shaded, which in this case would be 2/12.
Now, what's really quite neat about this, and by the way, I think people are used to seeing a model for multiplication where they're actually cross-hatching in 2 different directions and looking at the intersection. But that actually has some real problems with it as you move to multiplication of improper fractions. So now here is a picture very similar to the one we had before, but now we have several unit squares. And this allows me to use exactly the same area model idea to model the multiplication of 2, for example, 2 improper fractions. So here's 4/3 times 3/2. I've measured 3/2 along one dimension and 4/3 along the other dimension. Scoring by halves and thirds breaks each of those unit squares into 6 equal parts. So I can see that each of those parts is 1/6 of a unit square, and I have a total of, looks like 12 of them.
So I think I saw some questions here. That Mike, is there a way to explain why during division we flip the right side? And actually the way we've approached division here is not to think about that invert and multiply, but to, again, build off of the notion of equivalent fractions. And we really don't have time to go into this file right now, but it's a really kind of a different way to approach it, and it can explain and justify how you think, why that invert and multiply approach works. But it gets kids to think more about the notion of equivalent fractions, and that's kind of a baseline thing that they carry with them. And Mike has actually pointed out that not all the files are ready for use. We are hoping that they will be by the summer, early summer of 2014, and you could probably stop if you're going to be at NCTM. You could check with the TI booth and find out what their plans are for them. So we want to actually return to our PowerPoint right now, unless anybody has any other questions that they raised. Somebody has actually mentioned that this might help dispel some misconceptions. And I think that's a really important thing, that as we use the files and think about places kids have troubles that you guys were raising at the very beginning of the talk, how can we pose our questions and the things that we ask them to do with it, so that they will be thinking about what to do with these this baseline way of thinking about fractions. The really core idea here is that it's a consistent story. It's always A over B is A many copies of 1 over B. And even with that story, you can still have a way to think about fraction as a division. And so, I'm excited to notice that one of our observers, Tammy Jones, is going to actually be at T-Cubed and doing something with the fractions at the booth. That's really awesome. And so we're going to go back to the PowerPoint now. And Mike, how do I get back to the PowerPoint?
Just move your cursor under that green tab and stop sharing.
Right. sharing. All right. And one of the things that we kind of wanted to share with you as we're kind of wrapping up here is the notion here of not only is this an opportunity for kids to experience and work with fractions in a different way than they've ever done before, it's also an opportunity to exchange and get kids thinking out on the table, to really do what some of the formative assessment is calling for, is to find out how kids are thinking about it. So it's possible to actually give the kids a task like this, or like a couple of the other ones that we've looked at, and using Navigator, get something like this from the response to the kids to that question. And this is just an example of the kinds of things that you would say, well, what do you think? What do you want to do? So somebody has actually asked if they could stay late, and I don't think Mike allows that. So maybe we will just quickly show you if I will go back. Is that okay, Tom? If I try to pull up that file?
Fine with me.
Mike, is that okay?
Yeah, that's fine with me.
All right, so now I have to go back to sharing my desk and share my desktop, and we'll just quickly share that. Okay, and I have to go into, let's see,
Nspire.
down here, and open. So we weren't ready to do this one, actually, but we can maybe quickly get it, because I'm sure Mike won't let us stay later. So, sorry you're seeing all my stuff here.
Gail, it looks like you have a lot of files on proportional reasoning.
Yes, we do. Proportional reasoning is the next one that we're actually working on. So dividing fractions by a fraction is that. I think that's this one. All right, so the approach here is actually pretty simple. So if I want to say I want to divide, let's say 2/5 divided by 2/3, say I wanted to do that. So what I'm going to do, and remember now the students have had several exposures to finding equivalent fractions in very different forms. So what I'm going to do is generate different partitions and look and see how they relate to my original fractions, and continue until I get to something that has a common denominator. And here's the punchline. If you have 6/15 divided by 10/15, the 15s become irrelevant. The unit, it's 6 of something divided by 10 of something, and the answer really is 6/10. And so you have to think about what that means, but if kids get that experience, again, it's part of the consistent whole story. It's the notion of the number line, and it's the notion of copies, and what your unit fraction is, and that all kind of like hangs together and lets us figure out a different way to think about dividing, but it seems to us that it's pretty powerful. So I hope that helps, and I'm going to go back to stop sharing. And go back to the PowerPoint. And there's the story, and Tom's going to wrap that up in time for Mike to finish it up for you.
Okay. So we'd just like to emphasize that the thing that has attracted us to this is this emphasis of fraction as point on the number line really does buy this very coherent, consistent way to think. And we've really felt like our own understanding of fraction has been enriched by our work on this. We're really seeing now new ways to connect fractions meaningfully to not only back to students' previous understanding of whole numbers, but how it can be extended really nicely forward to more advanced areas. And just winding up, and we'll turn it over to Mike. This is just a list of all the titles of the files that we've created so far. So there's call it the suite building concepts, and there's 15 different files, and coming soon to a website near you. Yeah, we hope.
And okay. I'm going to now turn this back to Mike.
Thanks, guys. Wow, I know this was maybe intended for a younger audience, middle grades, elementary, what have you, but I really think I'm going to go in tomorrow with my algebra and calculus students and just double check that they have the same understanding that I want them to have, because I don't know that they actually do, and I think this is really going to hopefully shed some light on that. I really appreciate you guys putting these files together. So Gail did mention, and Tom mentioned as well, that these are going to be coming to a website near you. And I thought it would maybe be a good thing to share that website with everyone. So let me share my desktop. And you can get to the TI Common Core website by just typing in TICommonCore.com. You can access that through our website, education.ti.com, or just go straight there. Either way, these files should be available on the TI Common Core website, again, by early summer is what our hopes are. What's really awesome, though, is we do have a few files ready for you tonight. So 2 of the activities and then also the overview are ready to go. And so let me share that with you right now. So if you check out the chat window, there's some good stuff there. There's a certificate of attendance for tonight, which I know some of you may want, is available. As a reminder, that certificate is printed in English, even though the interface shows additional languages. And the documents link, there's a whole bunch of really good stuff in there. Gail and Tom's PowerPoints, my PowerPoint, all links are active. The 2 activities that I said were live, and also the overview. So there's some really great stuff in there.
Michael, can I just give one shout out again to Becky?
Yeah, absolutely. Go ahead.
She just did a great job, and she continues to change things to make them even better. So we're all just really grateful to her and for her hard work. So if you see her around, give her a thanks.
I concur. I really was impressed, Becky, with what you've been able to put together, and I know it's certainly been a team effort, but I know this is not easy. So thank you so much.